right, so those are pretty much the pieces. And we just have to think, how are we going to put these together? And so the first one, we want both of these things to be true. In other words, we want to get a 1 only if there's a 1 in both of these terms. So we'll multiply them. And so multiplication of these expressions does the same thing as an and. All right, and then multiply it by 0. And I don't need a dot here because 0 is a scalar. All right. So if both of these are true, I get a 0. The second one is, if x is less than -5, I get a 1, or sorry, -1, so I multiply that. And if it's greater than 5, I get a 1. All right, and because these conditions are all complementary, only one of them can be true at a time, then I can add them up. Okay, only one of them will give me a non-zero for a given element. All right. Now, of course, this can be simplified. Let me just do this first, and then we'll simplify it. All right, so that's what you get. But it probably occurred to you that you don't really need all of this, because if we're going to multiply by 0 here, well, we don't need the term, right? It's going to be 0 anyway. We can just take it out. And you don't have to explicitly write a multiplier of 1. That's always implied, so you can take that out. All right, so that's really all you need. And you can even make it a little bit simpler if you change the order. And now instead of plus minus 1, you can just say minus. All right, so that ends up being all you really need, but it's equivalent to all of this. And you can see we got the same result for both. All right, any question about how that works? All right. So the next type of operator is what's called a Boolean, and, or, and not. And just a quick review of how those work. And, which is this ampersand symbol, gives you a 1 only if both of its operands are 1s. Or you could say it gives you a true only if both operands are true. All right, so 1 and 1 gives you 1. 1 and 0 gives you 0. Or, which is a vertical line, gives you a true if either of its arguments is true. Right? So 1 or 1 will give you 1. 1 or 0 will give you 1. But 0 or 0 will give you 0 or false. And then you can turn a true into a false or vice versa by using the not operator, which is a tilde. Right? So if EX15 is 1, which is the same as true, then if we take the not of that, we get 0 or false. All right, now here's where MATLAB gets a little funny again. What happens if you apply an and or not operation to something other than 1 or 0? Well, it might be unexpected, but MATLAB will treat anything other than 0 as true. All right, so 2 and -5 is the same as 1 and 1 as far as MATLAB is concerned. And it gives you a true. Right, 6 and 0, well, now we've got a 0, so we have a false. So that gives you a 0, false. And not 100. Again, MATLAB just treats this as true. So you take the not and you get false or 0. And so if you've done programming in other languages, that might seem funny. You might have been expecting it to do something like a bitwise and or. That's not what it does. It just treats anything other than 0 as true. All right, something that you'll have to do sometimes is combining relational operations with Booleans. Okay, and this is how you do that. And so just thinking ahead to what we're going to cover in a week or two, and also reminding you of something you covered in 1181, like with an if statement. I want to do this block of code if either of these conditions is true. You would use an or. Or it might be, I want to do this block of code only if both of these conditions are true. So that would be an and. All right, so if you want to see if x is less than 0.2 or more than 0.3, here's how you do that. Okay, and of course, and since x in this case is 0.1, it's true because the first condition is true. Or if you want to test if x is between certain limits, you could use an and. Is x greater than or equal to 0.2 and less than 0.3? Well, I changed it to 0.5 here, so yes, it is. So I get it true. But the important point, you have to write it out this way. Okay, you have to have two complete relational expressions as the operands for this and operator. This will not do that. Okay, we see this mistake a lot because this is how you write it in mathematics. But this is not mathematics, this is computer programming. What this will actually do, so I mentioned this before, it'll evaluate these relational operations from left to right. So it asks, is 0 less than x? Yes, it is, so that's a 1. And then it asks, is 1 less than 1? No, 1 isn't less than 1. So I get a 0, when I should have gotten a 1. Okay. So if this is what you mean, then this is how you have to write it. Okay. So even though it looks redundant, you have to put x both times. All right, any questions about that? All right, and this summarizes the order of operations. So if you see some really complex expression, you want to evaluate it. Remember, parentheses, of course, always come first. Then the exponent is next. Then the not. So the not operator is actually relatively high in precedence. But then arithmetic, and then the relational operator. So it's important to remember the arithmetic operations have higher precedence than the relational ones. And then the Boolean operators are at the bottom. But and is higher in precedence than or. You may need to know that sometimes. So if you're thinking, do I need to put these in parentheses? You can refer back to this chart and say, oh yeah, I want this or to be done before the and, so I have to put it in parentheses. Okay, and then here are a couple that you can practice on. Try to predict what this is going to give you before you run it.